All right, so we're going to continue the series diving into the loot box. We're going to break this up into two parts. There's a lot to unpack in this part where we'll talk about the strategy and design of our loot box system, how we're going to actually do that, and then we'll talk through the code to give the player the loot box. So this video is going to be focused on the overarching design, the choices we're going to make, and then as far as giving the player the loot box. The second video will pick up when the player opens the loot box, makes a choice, and then receives the items that are inside the loot box. So this video will stop at giving the loot box. So first, we need to think about the different ways that loot boxes are represented in game. And these are just a couple of examples from other games. There's probably even more, but the first one, which I pulled from Fortnite, when you get a reward, it's largely just a UMG, right? So the loot box is represented in sort of a flat 2D animated UMG. You then open the reward, you get whatever was inside of it, and you move on. The second one is the clickable inventory model. This is heavily used in Guild Wars 2, where when you achieve an objective, you're given loot boxes in your inventory, which you then later open to receive the items inside the loot boxes. The third one, which I think I took out of Genshin, is in-world interactables, so chests that you might find throughout the world. These are, you can interact with them once. Multiple people can interact with the same chest. It's the same as a resource node, which is the next one I have next to it, right? So both of those kind of represent in-world loot boxes where you interact with them in the world, and other people can interact as well, and you get your corresponding reward out of either of those two. And then the last one I threw up there was looting a body that you killed, right? So this might be a bespoke interact where only the person who killed the mob is able to loot the loot box and no other players can loot it. So the difference is in the other two examples. In the in-world interactable, multiple people can interact with the loot box, each getting their reward. In the last one, only the player who killed the mob will get their reward. So those are kind of design choices to make. And fundamentally, no matter which of those 4 models or 5 models that you take, the basic flow is the same. So the basic design is that the server is the one who generates the reward. And you want the server to be doing that so that there's no cheating and there's no gaming the system, right? So the determination of whether a reward should be handed out is done on the server. They determine who should get that reward. They determine what that reward composition is. And then their job is to notify the client that they got a reward. Now, there's 2 different paths that I've outlined here. The top green arrow, maybe I should point to it. This top green arrow means after I've determined what the reward should be, if there is no choice to be made by the client, then I can just go ahead and give them the reward. So if there's no user interaction, no pick one of 3 type things, then I can just go ahead and give them the reward. If there is an interaction where you're going to make a choice, then upon notification of the reward, the visuals are shown on screen, whether that be some UI work, whether that be the physical opening of the chest in world, some sound effects and particle systems, whatever the case may be. And then usually a window pops up and allowing a player to accept whatever rewards they want. When they do make that choice, because they're going to influence what reward they're going to get out of the loot box, we need to validate that at the server. So on the server, we'll validate that the choice that they made was a valid choice and that there's no cheating going on there. And then we'll give the corresponding reward to the player, and then finally update the player's inventory on the client, which is just a representation of the reward. So no matter which of the design models we're talking about, these basic steps are going to occur. They're just going to occur at different timing, whether it has to be instantaneously decided or whether it can be delayed and opened at a later date and time. So if you remember from our other videos, we threw this diagram up when we were talking about selecting the character, and we had this selection component being sort of the dominant one. The one here in red is the one that dominates the selection process. Well, for the loot reward, we're largely going to be interacting with the inventory component. And so, our flow will start with the 3v3 scoring, determining that I've earned some sort of a reward. That will push down and notify the client that they've gotten an award. We'll also, at the same time, the server side will tell the scoring, the client side will tell the client. At the same time, we'll give the inventory to the player. The player will then accept any choices they have to make. We'll do a validation to make sure it is correct, and then everything is completed in the inventory component and then fundamentally replicated over to the client. So much of the work we're going to talk about, at least in this video, is almost exclusively going to be on the server, with the exception of the notification of the client that they received a reward. So there's three models that we thought about that might make sense for us. One is the straight UI, and at a high level, the scoring component would send a notification using a rep notify to the client. The client would present the UMG widget to the player, and then the client would do a request server RPC back with the player's choice of rewards. Now, the downside of this is that I have to make a decision right away. And in a case where I'm going from match to match and I might be wanting to jump right into the next round or match, I may not want to pause, stop, and think about the choice I have to make. It also means that if there's an unfortunate disconnect, between getting the reward issued to me, but me not selecting something, then it's largely going to get lost unless we do some special coding to hold that off into the corner. The inventory model, in this case, the scoring would just grant the inventory chest, and then, so the very first thing it would do is give the player the reward, and then it would send the notification to the client and say, hey, you just got an award, and the client would toaster up that reward on screen to let the player know that they got a reward. Now, the good news here is this is much safer from a timing perspective. If I get disconnected, I'll have already gotten the reward in my inventory, so I'll be better off in that scenario. And I can think about the choice I want to make when I'm not in the middle of a match, right? So I could be in a different persistent world, looking over my inventories, picking and choosing what rewards I want to have. So that inventory model has some advantages. The third one is the in-world chest, right? Where we would spawn a chest in front of the player. The player then interacts with the chest and gets their reward. So largely the same as the straight UI. The only difference really here is that instead of presenting a UMG widget, we first spawn an actor into the world. And we have to protect that actor that no one else can interact with it except the player that was intended for. The player then opens that chest and we present the selection UI. They make their choice. We then RPC back to the server to let the server know what that choice was. So the downside here is that if I didn't see the chest, I might run by it, not see it, not open it, not realize I have to open it to get my reward. And so there's a bit of a downside to that model as well. Same thing as if I disconnect between getting the chest spawned into the world and me opening the chest, then the chest can be lost. So for those reasons, it might seem obvious, we're going to go to the inventory model. So for this video, we're going to use the inventory system that we built out in our prior video as a bit of a backbone for this new LOOTBOX logic. So we're going to do that, and we're going to rely upon a couple of pieces that we've already coded. So if you haven't followed along in some of the other chapters, specifically, I believe it's chapter 5 on the inventory system and leading through 5 through 10, the inventory system and persisting the inventory system, some of the stuff might not make 100% sense, but just send me a message and I'll try to guide you to where you need to look. So in our prior video series, we had created this inventory management component as a child of the Lyra inventory management. So this is the standard Lyra inventory management component. We created our own child. In that child, we put in our persistent storage. We built out our ability systems, our skill systems, and our crafting systems. Now, looking back on this, we probably could have broke that into multiple pieces and been a bit more modular. But nonetheless, that's what we did in the other videos. But this allows us to then basically grab the UI work from that other series without having to rebuild an entire UI structure. So we have an existing inventory UI. We're going to go ahead and use it in this scenario. But what we're going to do is we're going to insert in the class hierarchy this loot inventory management component. So we're going to take Lyra, then loot, from loot to our main inventory management system. So this allows us to segregate the loot inventory logic from the rest of this logic into its own class. And then we went into a big, long cycle of, is it really necessary? Could we just put it in with the other components? And we probably could. But we wanted to just sort of keep it separate and distinct as we expand upon the loot system. Arguably, it's a simpler and cleaner approach. All right, so the first thing you need to do is jump into the editor and create your inventory management component. So you go into your your editor, you select the Lyra inventory management component as the parent, you create this new class, put it wherever you want to put it, and that'll generate your new C++ class. From there, we basically, this is the class that got generated by that step. So we have our new loot inventory manager component, which is a child of the Lyra inventory management component. We then went into our main inventory management component and changed its parent to be the loot. So you have to change the include statement here because that include is now moved up here. And then you include the loot inventory management component and make your main inventory management a child of the loot. So just changing that hierarchy structure a little bit to insert the loot inventory management component in the hierarchy chain. Then we needed a couple of functions and variables. So we have this bool flag, which, I'll try to explain this better. We really don't care whether it's true or false. We're using it as a way to communicate between the server and the client that a LOOTBOX event has occurred. And so you can think about it constantly toggling between true and false. And it's not whether it's true or false that matters, but the fact that it changed is what matters. And it's important to know that the server doesn't replicate to the client unless the value has changed. So if for whatever reason we made it true, then we made it false, then we made it true, it wouldn't replicate that because the end state variable is true and it started as true, so there's no replication. So it's important that you manage the flipping of the variable effectively to trigger the logic on the client. We're using an onRep notify, which is how the client is going to know that a LOOTBOX has changed, and that's where our visualization code will be. We have the reliable RPC call for making a reward choice. And so when we get to the second video, when we're actually selecting what items we want out of the LOOTBOX, this function will come into play. And then we have this notify client of award, which simply flips this trigger and fires off the replicate. So these are the functions and properties that we have set up inside the inside the loot inventory management component. The next thing we needed to do was to create a new inventory fragment. So in our other videos, we have fragments for abilities and skills and a bunch of different fragments. So we created a new fragment called our LOOTBOX. It has an item definition. So it's the, I should have said this. This is the structure, FLOOTBOX, FLOOT item, which represents one single item in a loot box. And that item has its definition class. How many stacks of it are you going to get? So in this case, I'm going to get one of this item. And what's the probability of me getting it? So in this case, it's 100%. I'm going to get this every time. So I have an item, I have a number of stacks that I'm going to get, and the probability of me getting it. So this is the loot item. We then have an array of those loot items for our selection and our guaranteed loot. So I can have an array where I might put 3 items in this selection box, all with 100% probability, and force the player to pick one of those 3. Consequently, I must also have the guaranteed loot, which says you're going to get all of the items in the guaranteed loot. And I may put a probability on that to say this rare item might be included 2% of the time. So the probability allows us to vary whether the items appear in the loot box. And then the 2 arrays say I can have certain things that are guaranteed player will get, and certain things that the player can make a choice. And then, of course, the probabilities allow us to randomize what's in that loot box. So when you add that fragment, so this is a new item definition, this ID loot box. I have my inventory fragment. So I have the visualization icon. I have my set stats, which is my stacks and my max stack count and whether or not it's in storage or not. And I have the new fragment loot box where the select one loot is an array and the guaranteed loot is an array. So I'm guaranteeing that I'm going to get 2 gold coins out of this 100% of the time. And then the only other thing is we're reusing our fragment ability to say that when you double click this item in your inventory, this ability is going to fire. And so by the same way we set up our abilities, we're going to use that logic again, but this time we're going to interact with the loot box, and that ability will be to give me the items and make the selection. So in our second video, we'll spend time focused in on this piece of the equation. But for now, what we're doing is we're setting up the loot box, the values of the loot box, and all the logic to actually give that loot box to the player. So we now have a loot box item. We need to go change our inventory system in our experience. So in our 3v3 experience, you start off by having the Lyra inventory management component added to every controller. So both the AI controller and the player controller get the Lyra inventory manager component. We need to change that. So we need to insert a new entry that says, if I'm a player, then I'll get the full inventory experience. But if I'm an AI, I still just need the Lyra inventory experience. So this says, okay, players, you get a more complicated inventory management system. AIs or bots, you get the basic one. So there'd be one entry here in your experience. We're going to create 2 entries. And it's important to note that we're not looking for controller anymore, but we're looking for player controller or AI controller, the 2 children of controller. So we need to make that change in our experience. Then in our experience, we have to grant the action set for inventory. So we have to let our players have all of the abilities to manage their inventory. And we just did a separate video on action sets. So if you're not familiar with action sets, go take a look at that video. But basically, by changing our default pawn, so from hero data shooter game to hero data persistent, we will persist our inventory through sessions. And then by adding the action set of inventory, we'll be able to perform all of the inventory actions. All right, so as a quick progress check, we created a new inventory manager to separate the loot logic into its own class. We've added that to our player controller, so our player controller has the loot logic embedded in its class hierarchy. We created a brand new item fragment for loot, which has its own properties that we can configure in the editor for what loot we want to drop. We then created our new loot box with that fragment, added some sample test data into that loot box. We used the gameplay experience to add the inventory system so that the various widgets, inputs, key bindings, and all of that are present in our 3v3 mode. And we stubbed out a new ability for the second video, which is going to be executed when we double click a loot box in the inventory. That's not part of this video, it's just a quick reminder. So the last thing really to do is how do we give the player that inventory, right? So we've set up all the bases for it. We now need to actually go about giving it to them. And the most logical place is in the scoring component. Since the scoring component is fundamentally tracking who wins, who loses, where are we in the match, was it a tie, it gives us a very natural place to hand over the loot boxes. And inside the scoring, we have this process victory event. So we have this process victory event where we determine whether the match is over or the round is over. Now, you may choose to only give a loot box when the match is over, or you may choose to give a loot box every time a round is over, or you may choose to do both. But this is kind of the natural place to insert this new logic on round over or on match over or both. So if you want to do it on the match over, then we created this new function, and I'll show it to you in a minute, give loot box to team. We pass the loot box in. Now we can get more complicated about how we determine what loot box, but for now, we're going to pass in a loot box, and we're going to pass in the winning team. So this team that comes over the match over is the winning team. And so you can choose to give stuff to the winning team, different things to the losing team, whatever you choose. But the two pieces of information you probably need here is at least who won the match and what to give them. From there, we basically do a quick authority check to make sure we're on the server. We get all the player controllers. We loop through each one of them and determine if their team is the winning team. So we may have 5 or 6 players, but only 2 or 3 are on the winning team. We're taking advantage that inside functions, the item ID gets its own variable created. We're grabbing our inventory component here. And if the teams are true, they match, and the inventory component is valid, we simply do 3 things. We give them the loot box. This is standard Lyra. So we say, here's the item. You're going to get one of them. We update our persistent inventory from our other video. And then we trigger the visuals. This is the new logic that we just created to say, okay, we're going to trigger some visuals on the screen for the user. So let's look at that new logic. So as we said, the on-rep loot box trigger is where we will perform the client-side visualization logic. But the server is calling notify client of awards, which just double checks that we have authority. If we do have authority, we flip the loot box trigger, which is the boolean that will trigger the on-rep notify to occur. And then if we happen to be the listen server, this won't replicate to the listen server, so we have to call the on-rep loot box manually for the listen server. So that basically sets it up so that we can give the inventory to the player and the player can interact with the inventory. So the player accesses the inventory windows from our different game experience. That's why we made those changes. We created a new inventory fragment so that we can randomize the loot drops. The scoring component now gives the player a loot box on the conditions that we choose. And that loot box will be persistent in their inventory on the data server until the player wants to open. So with that, we'll run the next video where we talk about interacting with the loot box and accepting your reward. Thanks for watching.